I thought I'd give you guys a little bit of help tonight to work on problem number 5. So we're given a rectangle inscribed in isosceles right triangles whose hypotenuse is 2 inches long. That's labeled for you. And if this is an isosceles right triangle, angle A is pi force 45 degrees, as is whatever this angle is, so B is 90 degrees up here. If you look at this smaller triangle, we have a right triangle down here at the origin, 45 degrees or pi fourths, which means this angle up here is 45 degrees, so B has to be at 0, 1. So the first thing we're supposed to do is, in part A, express the y coordinate of P in terms of x. So, well, I just want to put in x and get the y value right here, which is just the equation of this line. So let's see. A is the point 1, 0. And B is the point 0, 1. Hopefully you can do that in your head. The slope connecting those two lines is going to be -1. The y-intercept is 1, so that's just going to be the y coordinate is -x plus 1. Let's see if that works. So if I choose any x value here, I should get a y value that's on this blue line. So if I choose an x value 1, I should get a y value of 0, and that definitely happens. -1 plus 1 is 0. If I choose an x value of 0, I should get a y value of 1. -0 plus 1 is 1, and maybe something in the middle. So, well, what if I use x as a half? That'd be -1/2 plus 1. Y value is 1/2. Yeah, that makes sense, especially since the slope is -1. Down 1/2 to the right 1/2. That works out. Okay, so part B, we want the area of the rectangle in terms of x. So that's going to look like this. Area is in terms of x. Well, I do want length times width. One of those is pretty darn easy. Let's see, this length is from 0 to x is x, and then another x this way, so that's going to be 2x times, well, I could write this y value here, but I don't want y, I want in terms of x, which is why we did this last one. So I'm going to have -x plus 1, and if you want to, you could of course write that as what? -2x squared plus 2x, and that's area as a function of x. All right, so part C, we want the largest area the rectangle can have and its dimensions. Oh, I better start over here to the left. So we need to go back, and if I want to find the largest something, I'm going to look for where the derivative of that something, in this case the area function, changes from positive to negative. Let's see, area is already a polynomial, so I don't have to worry about this area function being continuous, but I suppose I do have to worry about the domain of the area function. And, well, x has to be in the first quadrant. Could x be 0? No, if x was 0, you wouldn't have a rectangle. We wouldn't have any width. And let's see, if x were past 1, I guess our rectangle would be down here. So 1's going to be the upper bound. Okay, that may help us later. So let's see. The first derivative of a prime, that's pretty easy. -4x, power rule, let's see, plus 2 power rule. That's nice and easy. And as we said, we're looking at a polynomial. We only have to worry about where this derivative is equal to 0. It's never going to be undefined. Let's see, so x is 1/2. Let's see, 1/2 of 4 is -2, plus 2 is 0. That works. So we need to make sure we get the change in sign that we're looking for. I think it does make sense that that's going to be correct. If we drew a tiny rectangle down here with, I don't know, a width of almost 2 and a height of near 0, its area would be near 0. Well, this area right now looks like it's not 0 at all. Okay, so let's see. We'll make a sign chart. 0 to 1. These are x's, and this is going to be the sign of a prime. All critical values, just the 1/2 in the middle. And let's see, what numbers can I use to substitute into a prime? Well, I'll use something super tiny, like 0.0001 times -4 is going to be a very small negative number, plus 2 is positive. And, I don't know, 0.9 times 4, well, anything more than a half is going to be more than 2, so we're going to get negative, I don't know, something more than 2 plus 2. That's going to be negative. All right, so that kind of tells us our answers. So this area function has a maximum at 1/2 since a prime changes from positive to negative at 1/2. I suppose I could write that out. I guess I'll just type it in. So we were not just asked for where that area occurs, but we want the area. So I guess the next thing I'm going to do area when the input is 1/2. And just go back here, that's going to be 2 times 1/2 minus 1/2 plus 1, which is going to be, well, that's 1 times 1/2 is 1/2. Does that make sense back here? Well, let's see. So x was 1/2, so that would be 1/2 this direction, and 1/2 that direction gives a width of 1 unit. And we already figured out this y value is going to be 1/2, so 1/2 times 1 is an area of 1/2. Cool. And, oh, I guess we just figured out the dimensions. If I made a mistake, let me know. Otherwise, have a good night.